Imagine solving a complex probability matrix perfectly in your head. You look right into the webcam, deliver the exact mathematically correct final answer, and the AI interviewer immediately fails you. When you jump straight from raw data to a final number without explaining the steps that got you there, you create a logic gap. To an automated grading system, skipping the process looks like a failure to understand the problem. These systems use chain of thought processing. They transcribe your spoken words in real time, listening for syntactical joints. Words like because, therefore, and assuming act as bridges that connect your ideas into a continuous logical path. Passing a technical screen is a test of your methodology. The system needs proof that your problem-solving structure is repeatable and mathematically defensible. The system monitors your microphone as closely as your math. When doing complex calculations, the natural instinct is to go completely silent. But automated platforms rely on voice activity detection. If the room goes quiet, the AI assumes you're done and terminates your turn mid-thought. To counter this, use speak-to-pause narration. You buy thinking time by saying out loud, "Let me structure my approach for a moment," or "I'm taking a few seconds to review the constraints." Narrating your hesitation keeps the microphone active. The algorithm categorizes this as a positive signal of an organized analytical framework. The algorithm is grading your state tracking abilities. Take the classic logic puzzle of measuring exactly 4 liters using only a 5-liter and a 3-liter jug. Start by building the environment. State that you are filling the 5-liter jug completely, then pouring it into the 3-liter jug until it reaches capacity. Declare the resulting variables out loud. The 3-liter jug is now full, leaving 2 liters remaining. If your next move is to completely empty the 3-liter jug, the AI needs to hear the new state. You would say, "I now have 2 liters in the large jug and an empty small jug." Declaring every state change explicitly removes ambiguity. It proves you have the engineering rigor to hold and communicate shifting variables. For senior quantitative roles, the system scales this up. If asked to calculate the probability of getting 50 heads in 100 coin tosses, you might identify the binomial formula. Calculating the exact textbook equation requires computing 100 factorial. The number is so massive, computer memory acts like old car mileage dials, spinning past their limit and rolling to zero. This integer overflow error shows the AI your calculation would crash a production server. Explain the hardware limitation out loud to the AI. You identify the overflow risk, then move to the normal approximation formula to safely extract a reliable answer. Navigating around that error shows the system that you possess both theoretical knowledge and the practical judgment required for technical deployment. If you realize you've made a mistake mid-answer, course-correcting out loud scores highly. It proves to the algorithm that your logic possesses an active internal validation mechanism. This methodology relies on 4 rules. Never go silent, state your constraints first, track every state change, and connect your steps using structural joints. Preparing for this format forces an organization of your own thoughts. You have to eliminate vague filler and organize scattered ideas into a step-by-step sequence. Training your brain to speak with this level of logic for a machine creates a foundation for more precise human leadership. Every conversation becomes clearer when you